Hey there, everyone. Here is a video for chapter 4, section 1, which is just systems of linear equations and two variables, and just kind of a brief chapter outline as well. So as you see down here in the lower right part of my screen, you'll see basically the notepad and where I'll take all my notes, and here will be the PowerPoints, and so you can follow along with them. 4.1 is review systems of linear equations and two variables. I think that's one you guys will remember from 1400 or previous classes you might have taken. 4.2 is going to be systems of linear equations and augmented matrices. So that's where we're going to take those systems of linear equations and we're going to throw them into matrices. And then 4.3 with Gauss-Jordan elimination, which is awesome, a wonderful way to use matrices to solve systems of equations. And then 4.4 will be matrices. We'll do basic operations. 4.5 inverses of square matrix, and matrix equations and systems of linear equations. And then finally, the Leontief input-output analysis. And that's how I'm going to break it down into those 7 sections. Our textbook should be that right now. It may change in the future, but. So 4.1 is review of systems of linear equations and two variables. So a lot of you guys might have already seen this. I'm going to make this a little bit smaller or just move it over here. Given the linear system ax plus by equals h, cx plus dy equals k, where a, b, c, d, h, and k are real constants, in other words, just numerical values, a pair of numbers x equal to x sub 0 and y equal to y sub 0. We also write that as an ordered pair, is the solution of this system if each equation is satisfied by the pair. And like we said, we're going to go through a couple of these. I have on another slide, we'll go through not these exact ones right here, but if you want to look at them, go ahead and take a look at them. I'm going to bring up Desmos here. Some of you guys might already know Desmos, but it'll be one way that I can show you a graphing tool real quickly. So anyways, if I ask you to solve each of the following systems by graphing. So I want to use Desmos, so I want to show you this real quick. So here's Desmos. I'm going to make the equations the top part of the screen. So we have A is the x plus y equals 4 and 2x minus y equals 2. And so in this case, that's this first equation right here. So if I was to plot it on Desmos, you'll see it looks like that. I'm going to make this just a little smaller so that way it takes up that part of the room. And I might move that. Bear with me a second. I'm just going to move this around so it's a little neater, easier to follow. And yep, there's the rest of that equation. 2x minus y equals 2. Oops. So in this scenario, basically we plot those two and we see where they intersect. And what's so nice about using Desmos or some of your graphing calculators is that it'll plot the points for you and show you right where they intersect. So this would be the intersection of 2, 2, which would mean this is a unique solution. It is consistent and it is, yes, consistent and it's a unique solution, so it's dependent. Yep. And now let's go to the other one. Let's go B now. So I'm going to unmark these. And you can type these in just like normal equations, but I just had them already typed in because it was quicker. Oh, did you notice that? So 6x minus 3y equals 9. If we divided a 3 out of each of these terms, in other words, factored a 3 out of both sides, this equation, we'd actually end up with 2x minus y equals 3. And you'll notice that the line is purple is the same line as it's green. Those are lines that are coinciding lines, which means basically they lie right on top of each other, which means there are infinitely many solutions to that system. In other words, they are linear dependent and they're not linear independent. Now, if we go to the last one, so we have 2x minus y equals 4 and 6x minus 3y equals negative 18. Yep, if you can see it right there. And hit that. You'll see that these are two parallel lines. In fact, if you were to write out their equations, divide this side by 3 on both sides, you'll see that basically it's 2x minus y equals, I think, negative 6. So then you get these two basically parallel lines, which means there are no solutions. So going back to here, if you look at this, you'd have unique solutions, you'd have infinitely many solutions, and no solutions. And to kind of use some vocabulary terms to summarize that, a system of linear equations is consistent if it has one or more solutions and inconsistent if there are no solutions. So I'll show you here on another slide, kind of what I just showed you in a second, but in a formal definition. Furthermore, a consistent system is said to be independent if it has exactly one solution, often referred to as a unique solution, and dependent if it has more than one solution. Two systems of equations are equivalent if they have the same solution set. So make this a little smaller here. And so you have this linear system, right? That's what we know, must have either exactly one solution. So that's consistent and independent. That's this part right here. That was the first example. And then there could be no solution, which is inconsistent, which is two parallel lines, which was our third example on that previous one. And then C, we have infinitely many solutions, consistent and dependent. Dependent meaning that they depend upon each other. And you'll see that they are coinciding lines, which means they have infinitely many solutions. And as you'll note, there are no other possible solutions. And by the way, this is for two variables, okay? So first we look at everything in kind of the simpler terms, which is two variables. We're gonna move to 3 variables, 5 variables, n variables in terms of how we solve these, not necessarily graphically, but you'll see with basically doing matrices and the Gauss-Jordan elimination method. So solving systems by substitution and by elimination. So I'm going to show you this by hand. Some of you guys might already recognize this, so you can probably fast forward if you don't want to watch all this. But in the first example, we have 3x plus 2y equals -2, and we have 2x minus y equals -6. And so what I'm going to do in this first case is let's do substitution first, okay? So I'll call it sub. So if I'm going to sub, that basically means, and this is not focusing. Is that better? Yeah. We're just going to sub, which means we're going to solve for one of these variables for their term. So in this case, I'm going to move y over here and move 6 over here. So in other words, 2x plus 6 equals y, right? That's this one, just rearranging variables, right? I add y to both sides, add 6 to both sides. That's how I get this. Now I have it in terms of y, and then I'm going to put it back into that first equation. So I'll have 3x plus 2 times 2x plus 6 is equal to -2. And then all I need to do is distribute this out. So I got 4x plus 12, and this is 3x here is equal to -2. So minus 12 from both sides. And now I got -14. See if that focuses it. Oh, it's not really focusing right now. And then I have 7x here, and basically you get 7, divide both sides by 7, and so you get x is equal to -2. And then if you have this, all you need to do is then plug it back into that first equation that was in terms of y. So we have 2 times -2 plus 6 is equal to y. Well, that's -4 plus 6 gives me +2. So in other words, y equals 2. And now we have solved both of those equations. I wonder if it's because I'm using white paper versus the yellow paper I normally use. Anyways, that's one way, that's substitution. Now elimination. But I sure hope I'm recording. Elimination here is going to be the 3x plus 2y is equal to -2, and we have 2x plus a -y is equal to -6. Now, one thing to keep in mind is when we have these ones we want to do elimination, some people also think of them as elimination through addition. And so in other words, I'm going to multiply this whole equation here by 2, because then I can add these two equations together and you'll see that the y's drop out. So we'll do 2 times this whole entire quantity. So I have 4x plus a -2y is equal to a -12, right? Yep, right? And now I'm going to add this equation and this one together. And basically I'll have -2 plus -12 gives me -14. 2y plus -2y gives me 0y, and then 3x plus 4x gives me 7x. So I have 7x is equal to -14, divide both sides by 7, I got x is equal to -2, which is the same x equal to -2 we got up there, which should be not a surprise because it's just the same system of equations, we're just solving it a different way. And then we go back in and we plug it into either one of these and we should be able to get the answer for it. Let's just plug it into that 3x plus 2y one and see what we get for y. So I got -6 plus 2y is equal to -2. I'm going to add 6 to both sides. I'm going to do that right below here. So I'll have 2y is equal to +6 plus 6. That becomes +4 divided by 2. and I get y is equal to 2. Sorry, I'm trying to make sure that it stays on the screen for you. There you go. So basically, that's how we can do those ones. I'm not going to do the second example for you. You guys can do that for practice on your own if you'd like. So we're going to do this one instead, which basically is a story problem. So this is an application. Dennis loves cottage cheese and yogurt and wants to increase the amount of protein and calcium in his daily diet. And an ounce of cottage cheese contains 3 grams of protein and 15 milligrams of calcium. An ounce of yogurt contains 1 gram of protein and 41 milligrams of calcium. How many ounces of cottage cheese and yogurt should Dennis eat, each day to provide exactly 62 grams of protein and 760 milligrams of calcium? Click this page off. New one there. So now we got a new one. And so we want to set this up so we can solve this now. And in this case, one thing we want to keep in mind is what is our variables? What are we thinking of? In this case, it's how much cottage cheese you can consume and how much yogurt you can consume, right? So I'm going to call X is cottage cheese, or basically the amount of cottage cheese. And Y is going to be the amount of yogurt. Got it? Yeah. And now your textbook likes to do this example of setting up a table. And I think that's a pretty good way of looking at it. So if you set up a table, we have X's and Y's. Yeah. Right. That's our yogurt. And then we're going to have basically our constraints of like protein and calcium, which I'm sure I spelled wrong, calcium, and then the total need. So in this case, he gets 3 grams of protein from cottage cheese and 15 milligrams of calcium. And he gets 1 gram of protein from yogurt and 41 milligrams from calcium. And let me put this total needs instead along here. Because if you think about it, what our constraints are talking about is the total amount of protein needed, right? So total amount of protein needed is he wants to have 62, right? And he wants to have 760, and I'll put milligrams in here and grams here just so that way that's a little more clear. Now what's cool about that is we can take and make an equation with that. So if you see we have a 3x plus a 1y equals 62. We call that basically our protein constraint. Right? And then we can also do that for calcium as well. So why don't you, I think you probably can guess what it should be. Yeah, 15x plus 41y is equal to 760 milligrams of calcium. So we call that our calcium constraint. And now what we need to do is just solve this. So either by substitution or elimination, and then we can get a value for it. So based on that, I see that this is a y, just a y variable. So I'm going to do substitution. I'm going to do substitution, and I have y is equal to 62 minus 3x. Does that make sense? Hopefully that makes sense for you. Yeah, we could do that, or we could do elimination. Yeah, that's fine. We could do that way. And so if we put y in there, we'll have 15x plus 41 times 62 minus 3x is equal to 760. And we can solve it that way. And we're going to get big numbers. So this is where, for example, it might have been better to have done it the other way around. But let's do this one. So 41 times 62. Hopefully you guys got 2,542. And then minus 3 times 41, which should be 123x, is equal to 760. And now here's where we collect like terms. The 15 and the 1 23x. So I got negative 108x. And then I got to move this to the other side. So I'm going to minus 2,542 from both sides. So I got negative 108 divided by, or not divided by, but equal to negative 1,782. And then I'll divide both sides by negative 108. And I'll have x is going to be equal to 16.5. And then I can find y by taking x and plugging it back in up here. So in other words, y is going to be equal to 62 minus 3 times 16.5, which should be 12.5. So in other words, that's 12.5 ounces of yogurt, right? And this is ounces of cottage cheese, CC. Kind of neat how you can do that. We could also have done the elimination method. We could have made this probably multiply this whole thing by -5 and then add it to this one. That would give her our 5x. And then we just add these together and go down that way as well. So either way, I think the more important part is setting this problem up, right? You got to have your, what we will call, or learn to call these, our decision variables. What are the variables that we are able to change? What are our independent variables? And how do we impact or solve our solution? And that's that one. All right. So the next one we have is supply and demand for soybeans. At $4.80 per bushel, the annual supply for soybeans in the Midwest is 1.9 billion bushels, and the annual demand is 2.0 billion bushels. When the price increases to $5.10 per bushel, the annual supply increases to 2.1 billion bushels, and the annual demand decreases to 1.8 billion bushels. Let's assume that the price supply and price demand equations are linear, okay? So first we got to find that price supply equation. So I'm going to take that out, and now we'll use this. So in this case, what we probably want to do is we'll make a table again. I'll call it P meaning price. I'll call it supply. We'll call it demand, because those are all the pieces of information we're given, right? If we think about reading our story problem again, what is the information we're given? Well, we're given at $4.80. The supply is 1.9 billion bushels. I'm just going to write it as 1.9. And the demand is 2.0. In other words, in this case, right, the price is too low, the demand is too high, there's not enough supply, so it means a surplus, or a shortage, sorry. And then in this case, we have $5.10. I would assume it might be the opposite. There's too much supply because suppliers can get a lot of money for it, but the demand has probably gone down. By the way, if you remember from your economics courses, demand is usually downward sloping and supply is upward sloping. So we'd expect those two lines. So first, we're being asked to find the price supply equation. So we're finding that we're probably just going to use this and this piece of information, those boxes, right? The prices and the supply, right? Here, just if you ever always get confused, draw a graph if you're looking at two variables. Usually price is on the y-axis and quantity is on the x-axis. And so basically we're just going to plot those, right? And in this case, right, hopefully supply would be an upward trending line like that, right? If we look at this, supply of maybe 1.9 is here, maybe 2.1 is here, and 480 is here, and maybe $5.10 is here. So we got there, and we got there, something like that, right? And two lines, 2 points determine a line. So we got basically our supply line. But we need to come up with the equation for that line, right? So we need to come up with the slope. M is going to be equal to 5.10 minus 4.80 divided by 2.1 minus 1.9, which can give us 1.5 is our slope, positive slope, which makes sense. That's what our line tells us. And now what we need to do is come up with basically our intercept. And so if we write it in point slope form, we can do price, y, minus 4.8 is equal to 1.5, the slope, m, times x minus 1.9. And doing some rearranging, we get 1.5x minus 2.85 is equal to negative 4.8. And this is p, so we get p is equal to 1.5 x plus 1.95. And so now we got a price demand equation for that. Now, am I remembering, what is this equation? This is point slope form, right? And so you write it as like y2 minus y1 is equal to m times x2 minus x1. That's the point slope form. You can write it in that way as well. But this is in the y equals mx plus b form, right? So you can use this to write it in this way too. All right. B, we need to do the same exact thing except for the price demand equation. And in this case, I would be willing to bet 1 point is probably like right here, right? And 2 is probably right here for 480. And we might have a line like that, right? Yeah, that would probably be our demand, right? And this is our supply. So let's go in and put this up here in price demand equations. So in this case, again, we got to find M the same exact way. So M is going to be equal to 5.1 minus 4.8, which shouldn't look that unfamiliar. It's the same, basically Y values, and now the X values change. That's going to be using, oops, sorry, you can't see that, this bottom piece right here, because that's our X is our demand, the quantity demanded. So we're going to go put that in there, and we'll have 1.8 minus 2.0, and we end up with 0.3 over negative 0.2, which ends up being negative 1.5. And now we need to do that into our price demand equation. So we can do it as this way, negative 1.5 times the quantity demanded plus B, right? This is our y equals mx plus b form, right? So in other words, slope intercept form, slope and intercept. And now we just take one of these points from above, right? So the 2 and 4.80, or the 1.8 and 5.10, and we just plug it into this equation. So in this case, if I'm going to take the $5.10 as my y value, and negative 1.5 times 1.8 plus b, we can solve for b, and b should be 7.8. In other words, the price demand equation, PD, is negative 1.5 Q plus 7.8. And that should make sense, right? Negative slope. Y-intercept is probably higher than 5.0, right? Which is the 7.8 down here. Now that we have those two, we want to figure out C, which is our find the equilibrium price and quantity. Well, that means that basically we need to figure out where they intersect. So we could do the graphical approach, which is where we graph the two lines and figure out where they intersect. We could also solve the system of equations that we have, right? So we have basically P is equal to 1.5 X plus 1.95. And technically this is the price supply and this is the price demand. And we have negative 1.5. I put X, it should be Q, but we'll call it Q. Q plus 7.8. It's technically working that way. And technically the price supply should equal the price demanded at the equilibrium. That is basically where we say P. And so this is where sometimes you'll just see people skip and just have price and quantity. But basically what you're saying is that the price, this is the equilibrium price. So there are two equations. Now, if we add these two together, Q's go away, right? So we get 2P is equal to 1.95 plus 7.8 gives me 5, 7, carry the 1. I think that gives us 9.75 divided by 2. And hopefully our price is going to be equal to $4.87 technically, but it'd be 88 cents if we round up. But that's our price. And then once we have that, we can pick either one of these equations and we just plug it back into there. And so this is our equilibrium price. I'm gonna run out of room right in that equilibrium price. And so our equilibrium quantity, Q, is going to be equal to 1.95 bushels. Okay, and so that was in price, bushels. That's in, I think, billions of bushels. Yeah, billions. And so 1.95, that should be our X value, right? So if we go back up here, here's 1995 should be right. Oh, look at that. I drew this really well. 1.95 is there. We go over here. That should be that 4.875. Looks like we're pretty dialed. That was a really good graph. And I think that was the last part. Graph the two equations in the same coordinate system and identify the equilibrium point, the supply and demand curve. And we already got that done. So there you go. Hopefully that helps.